Hello everyone, in this video we're going to learn on how to write electronic configuration. And electronic configuration can be written in two ways. Number one, you can write that in the SPDF notation, or you can also write it in the orbital diagram format. We're going to look at both formats in this video. Let's try problem number one, shall we? Now, we need to write the electronic configuration for aluminium and aluminium 3 plus. And how are we going to do this? The first thing you need to do is to identify what is the proton number, or in other words, the atomic number for aluminium. Aluminium is a species given to us. So we need to know what is the proton number. To do that, we can go to the constant values and RAM table right here. And as you can see, aluminium, symbol Al, the atomic number. Another term for atomic number is proton number, is 13. We have 13 proton right here, 13. Therefore, the number of electrons for this, number of electrons will be the same as the number of proton. And we're going to do slightly different thing for aluminium 3 plus, because as you know, when you have a charged species over here, especially for a cation, you're going to take out some electrons. First, let's do the electronic configuration for aluminium. We know that the proton number is 13 and the number of electrons is 13. We're going to start with the SPDF notation. For aluminium, the SPDF notation should be, we're going to start with 1s first. So 1s, 2. So you have 2 electrons in 1s. And then you're going to go to 2s, 2s2. That is 4 electrons. Remember, we need to have 13. And then you're going to fill in 2p, 2p6. Okay, that is 10 electrons. 6, 7, 8, 9, 10. So 10 minus 13, you have another 3. So the remaining 3 will be entered in the 3s. So you have 3s2. You have another 1. So the other one will be in 3p1. So let's have a look at the electronic configuration. 3s2, 2s2, 2p6, you have 10. And then 3s2, 3p1, you have 3. So 10 plus 3, you have 13. So this is the SPDF notation. Okay, what about for, we're going to write down the orbital diagram. So the orbital diagram should be, you have 1s, 2s, 2p, 3s. So note that you will have some space over here in between, but for 2p, they will be degenerate. So the space is smaller in comparison between 2s and 2p. And you have 3p, 1, 2, 3, 3p. So you have 2 electrons here. Okay, 2 electrons. And you have 2 electrons here. You have 6 electrons right here. And then you have 2 electrons in 3s2. And you have 1 electron in 3p1. Okay, so what about Al3 plus then? So Al3 plus means you are taking out 3 electrons. So you're going to take out 1 electron, 2 electrons, 3 electrons. So you're going to take out 1, 2, 3. So these are the electrons will be taken out first because they are the furthest away from the nucleus. You can imagine that you have a nucleus over here. That one will be the closest to 1s, and thus these are the electrons at the outermost shell. Okay, so you can imagine that. Okay, so this is shell number 1, shell number 2, and shell number 3. So this n equals to 1, n equals to 2, n equals to 3. So these are the outermost shell. Okay, so now this is going to be the outermost shell or valence shell. So that is what it meant by outermost shell, valence shell. So these are the valence electrons. Okay, so those are the valence electrons. So the valence electrons will be taken out first if the aluminium will be getting ionized. Therefore, the SPDF notation would be 1s2, 2s2, 2p6. You have 10 electrons, 6, 7, 8, 9, 10. Okay, because you minus 3. And the SPDF notation for that one, for the orbital diagram, you have 1s. Okay, so you're going to have some space here, 2s, and some space. Now it's quite close for the 2p, so you have 2p. So this is the electronic configuration for aluminium 3+. Okay, now what about chlorine? This time you have chlorine with additional electrons there. So let's have a look at the proton number. We have 17 for chlorine. So the proton number is 17. Therefore, for chlorine, the electron will be 17 electrons you need to fill in. But for chlorine minus, you will get 17 plus 1. Okay, so for chlorine, the SPDF notation would be 1s2, 2s2, 2p6, 3s2, so 2s2, then you're going to fill in there. So 6, 7, 8, 9, 10, 11, 12. So you have 12. And how you're going to make it 17? So you're going to fill it up until p. So 3p, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So you put 5 here. So you have 17. And the orbital diagram, you're going to have 1s, 2s, 2p, 3s, 3p. Okay, so you have 2 electrons here, 2 electrons there, 1, 2, 3, 4, 5, 6, 3s2, 1, 2, 3. You're going to do that one first. Okay, then you're going to fill in doubly. 3, 4, 5. Okay, now you're going to add 1 electron. So where are you going to put that additional electrons for Cl minus? For Cl minus, then you're going to have 1s2, 2s2, 2p6, 3s2, 3p6, because you're going to add 1 electrons here, isn't it? Therefore, for the orbital diagram, 1s, 2s, 2p, 3s, 3p. Okay, 1, 2. Okay, 6, And then for P, get like that. Okay, it's quite easy. Now, what about titanium? You have Z equals to 22. So for titanium, 1s2, 2s2, 2p6, that is 10. 3s2, 3p6, 4s2, that is another 10. So you have 10, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10. So now you have 20. So the other two electrons will be going into, okay, you have done this, you've done that one, you have done this, you have done this, and the remaining two electrons will be filled into the 3D orbitals. So you're going to get 3d2. So let's have a look. 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 20, 22. But do remember, once you start filling in electrons in the 3D, even one electron, then you're gonna start to have this orbital to be shifted to the other side. This one will move to higher energy level. Okay, so the electronic configuration you should consider writing is, okay, so all of this will be the same. 1s2, 2s2, 2p6, 3s2, 3p6, and 3d2, 4s2. It's only between 4s and 3d you're going to switch places. So this is going to be the better one to be written in exams. And the orbital diagram, so you have, okay, so you have 1s, you have 2s, okay, 2s, 2p, 3s, 3p, 1, 2, 3, 4, 5, 3d, and 4s. So you have 2 electrons here, 2 electrons there, 6, 3p6 right there, and 3d2, 1, 2, and then 4, oops, 4s2. So this is the orbital diagram for titanium. So it's quite easy. Do remember, for D block elements like titanium, once you reach 20, when you exceed 20, if you start to fill in 3D, the D orbital will go to a lower energy level and 4s will go to a higher energy level. So that is the only thing you need to remember from this video.